What if I told you that one of the world's most popular toys actually holds the key to understanding really, really great engineering? Yeah, it's not just about stacking blocks, it's a whole way of thinking. So let's break down what these little plastic pieces can teach us about design.
Okay, so this is the big one. This is our essential question for today. We're going to unpack this piece by piece, pun intended, because the answer, well, it reveals a fundamental truth that applies to literally everything, from a toy bridge all the way up to a skyscraper.
Before any engineer can build something incredible, they have to know their tools inside and out. For us, that means learning the specific vocabulary of our parts. It's about looking at a pile of plastic and not just seeing a mess, but seeing a whole toolkit full of possibilities.
First up, you've got the classic brick. This is your workhorse, right? Your foundation. When you need to create solid mass, build up a wall, or just lay down a base, the simple interlocking brick is your go-to. It's all about strength in numbers, just simple, effective stacking.
Next, we have the plate. Now, it might look like just a squashed brick, but that thin profile, that's its superpower. It lets you add all kinds of detail, create different levels with real precision, and, this is key, you can overlap them to lock larger sections together, which adds incredible strength without all the bulk. Now let's talk about the beam. You should think of these as the skeleton of your creation, kind of like the I-beams in a real building. They're designed to build strong, rigid frameworks that can span big gaps and support a lot of weight. And those holes, they aren't just for looks, they are crucial connection points. And here's where we get things moving. The axle is a total game changer. It's a simple little rod, but its purpose is huge, to let things spin. So if you want wheels that turn, a crane that pivots, or a propeller that actually rotates, the axle is the piece that makes it all happen.
So, if axles introduce motion, gears are how you control it. These little toothed wheels are basically the heart of any machine. You mesh them together, and suddenly you can transfer power from one spot to another. You can make things go faster, you can slow them down, or you can even change the direction of the spin. This is where things get really interesting.
And finally, we have the connectors and pins. Honestly, these little parts are the unsung heroes of any advanced design. They're like the specialized glue that lets you connect beams and axles at just the right angles, creating strong triangles and complex shapes that you could never, ever make with just simple stacking.
So, we've got a vocabulary down, we know our parts, now let's put it all to the test with a classic engineering problem, the bridge challenge. This is where we go from just knowing what the parts are to really understanding how to use them. The goal here is simple, but it's really specific. Build a bridge that uses at least 5 of the different part types we just talked about. This little rule forces us to be intentional, to actually think about our design choices, instead of just grabbing whatever's closest. And look, we're not just going to start snapping pieces together and hope for the best. Real engineers, whether they're building with plastic or steel, they follow a very deliberate process to solve problems. Let's walk through it.
The whole process really has 4 key stages. First, you sketch. You plan your idea out before you even touch a single piece. Second, you build. You turn that idea into a real thing. Third, and this is so critical, you test it. Does it hold up? Is it stable? And fourth, you share your results. You talk about what worked and what didn't.
Following that process, especially those last 2 parts, testing and sharing, that leads us right to the core lesson of this entire thing. This is the aha moment. This is where it all clicks.
This right here is the most important step. The real work isn't just in the building itself, it's asking this question after you're done. Which parts were the most useful? Was it a beam that helped you span the gap? Was it the connectors that made a strong triangular truss? Understanding why a certain choice worked, that's where the real learning happens.
And there it is. That's the secret sauce. That's the answer to our big question. The secret to building stronger, better, more interesting designs isn't about having more bricks. It's about knowing the unique job of every single part in your toolkit and choosing the right one for the right job.
I mean, just look at the difference it makes. When you really know your parts, you get intentional design, you get real structural integrity, and you can create complex functions. But when you're just building blindly, well, you might get lucky once in a while, but you're way more likely to end up with something that's unstable, wasteful, and frankly, just kind of boring.
And this idea, this principle, it scales up big time. Think about it. An automotive engineer choosing a very specific alloy for a car's chassis, or a civil engineer selecting exactly the right kind of reinforced concrete for a skyscraper. They're doing the exact same thing. They're selecting the right component for its specific job to make a much grander design work.
So I'll just leave you with this question to think about. This way of thinking works everywhere, from the ingredients in a recipe to lines of code in a program, or even just the ideas in an argument. What are the fundamental building blocks in your world? And how could understanding them just a little bit better help you create something truly remarkable?